Hey guys, you got a test tomorrow over thermodynamics, so I'm going to be going over the review with you. Um, Not all of it because some of it's definitions or stuff you can find in your notes, but I'm going to go over some of the ones that have correct answers so you can know that you got it correct. All right. For number two, identify the following as convection, conduction, or radiation. All right. Um, let's see. A direct transfer of heat through contact. Anytime you're touching something and you feel the heat, that's going to be conduction. Okay, again, conduction. All right. B, can travel through empty space. Examples are like feeling fire's heat, right? If heat is traveling through space, that's going to be radiation, right? Currents of gases or liquids, all right? Anytime it's circulating, that's convection. Okay, convection is to circulate heat. All right, so D, hot air balloon rises when hot air is pumped into it. Okay, so if the hot air rises, that's the circulation of the heat. So that's also going to be convection. All right, then E, a microwave heats up food. Okay, the food is not over and is not touching anything. It's all being heated up through the air. So this is radiation. All right, number 7, the metal handle of a pan is hot after being left on the stove. Okay, so the metal pan is hot after being left over the stove. It is touching the stove, so this should be conduction. Boiling water in the tea kettle. Okay, the boiling water is the hot air is rising to the top. All right, and the cool air is sinking to the bottom. That's why if you look inside a pan, it's circulating, okay, which makes it convection. You get burned from touching the hot kettle, conduction, and you feel heat from the heat source in the kettle without actually touching it, okay? That's gonna be radiation. All right, let's see. I'm going to skip to 9 because you should be able to answer the 3 through 8 with your notes. All right, so number 9, describe what scientists mean by specific heat. Okay, specific heat is talking about how much energy it takes to raise 1 kilogram of a substance by 1 degrees Celsius. All right, so I'm basically saying the definition of specific heat right there, but that's what they're talking about. Okay, that's what they mean is how much energy. Some things it doesn't take a lot of energy to raise, like aluminum changes its temperature very quickly, right? That's like if you have a potato wrapped in aluminum in the oven, right? When you take it out of the oven, the aluminum's very hot, but if you set it on the counter, wait 2 seconds, then touch the aluminum, it's cooled down and you're not going to burn your hand as much. Okay, if it's touching the potato, you'll burn your hand, but if it's not touching the potato and there's air between the aluminum and the potato, then you can touch the aluminum, right? But if you were to do that with another material, like firewood stays hot after the fire's done with it, okay, because it takes longer for heat to change its air. Boiling water stays hot even after you turn the heat source off for a while. Okay, number 10, which object would transfer heat faster? Water with a specific heat of 4,180 or copper with a specific heat of 0.39? Okay, the answer for number 10 should be copper. Okay, the smaller the number means the less energy that it needs to transfer heat or to raise 1 degree Celsius. Okay, and I realize that should be Celsius, not seconds. Another correction I need to make before you guys get copies of this. All right. Number 11, which substance would heat up the fastest out of silver, iron, brass, and carbon? I'm actually not going to answer this one for you. You look at your notes over measuring heat. It has all the specific heats listed there. Tell me which one's going to heat up the fastest and why. All right, number 12, why does a substance with a high or low specific heat conduct electricity well? All right, because if it has a low specific heat, that means it's more than likely more metallic. With metallic bonds, the electrons are in the sea of delocalized electrons. So the electrons don't belong to one nucleus. They belong to everyone. So that allows whenever a metal's connected to an electric source, it allows it to travel faster through the electrons versus if it's in an ionic or covalent compound where they're set in place. All right. So now for 13, 14, and 15. Okay, so for number 13, or with all of these, we're going to be using the Q equals MCAT equation. Okay, so for number 13, what would be the heat? So we're looking for the heat transferred if the temp of a 0.95 kilogram of water changes from, so initially was 13 degrees Celsius to 84 degrees Celsius. All right, and then it tells us the specific heat of water. All right, so I can plug this straight into the equation. All right, so when we do 0.95 times the specific heat, 4,180, times the change of temperature. Remember, it's always final minus initial. All right, so 84 minus 13. When you plug these all into the calculator, you should get 281,941 joules. All right, number 14, what is the temperature change when 100 joules of heat is added to 0.20 kilograms of copper? Sorry, this is another mistake I found where I fixed it on your copy. All right, let's see. All right, so now it's asking us to find the delta T. All right, so it gives us the Q of 100 joules. All right, let's see. And it gives us a mass of 0.020. And it tells us that the specific heat in this case is 385. And we're looking for the change of temperature, just the overall change of temperature, not the final or the initial, just the overall change of temperature. Okay, so if this is my equation, and I'm trying to get delta T by itself, then I'm going to move the mass and the specific heat to the opposite side. So my equation is going to look like Q over MC is equal to the change of temperature. Okay, when you plug these numbers in, your final answer should be 13 degrees Celsius. All right, so make sure you plug those in the calculator and that you get the same answer as me. All right, if you're on level, this is all you gotta know. If you're pre-AP, let's do one more question or one more problem. All right, it says a piece of metal weighing at 0.059 kilograms was heated to 100 degrees Celsius and then put into 0.1 kilograms of water. Just so you guys know why I changed this on your paper versus mine, it said 100 milliliters. Okay, 100 or 1 milliliter is equal to 1 gram of water. All right, so if we have 100 milliliters, that gave us 100 grams, but we needed to know it in kilograms, so that's why I just went ahead and changed it for y'all. All right, it's initially at 23.7 degrees Celsius. The metal and water were allowed to come to an equilibrium temperature, determined to be 27.8 degrees Celsius. Assuming no heat is lost to the environment, calculate the specific heat of the metal. All right, so I gave you guys some hints. First, calculate the heat absorbed by the water, then use the value for Q to determine the specific heat of the metal in the second calculation. Okay, so first we're going to do water, okay? So Q water. All right, tells us the mass of water is 0.1 kilogram. we know the specific heat is 4,180. And then the change of temperature, let's see, it initially was 23.7, but its final is 27.8. So minus 23.7. All right, so plug that into the MCAT problem. When you do that, you should get that Q is equal to 1,713.8. Okay, so now we're going to go to the second step, where we're going to use this Q value. To figure out the specific heat of the metal. Okay, now I'm gonna make this negative because the metal, let's see, hold on, we know the mass of the metal. We know the change of temperature because it went from 100 degrees Celsius. Nope, sorry, it went from the final was 27.8 and it started at 100. Okay. And we're looking for C. All right, but the reason that this is negative is because it's losing heat. It started at 100 degrees Celsius. It started at 100 degrees Celsius and went down to 27.8. So that means it's losing the heat, which is why it's negative here. Okay, and the water was here, the water was gaining heat. So that's why it's positive. Okay, but so now I'm going to again do the Q equals MCAT. But now I'm trying to get C by itself. So we're going to divide by the mass and the change of temperature on both sides. So Q divided by the mass times the change of temperature. And you should get a positive number because that's going to be negative. All right, it should be 402.3, and the units would be joules per kilograms degrees Celsius. All right, so I hope that makes sense. I hope you guys are doing well and feeling comfortable with this. Tomorrow is going to be a good test day.